All right, section 6.2 is transforming random variables. Now, we've done linear transformations on data sets. If you recall, when you perform a linear transformation on a data set, if you multiply every data point by b and add a, it does a certain thing to the data set. If you recall, the shape stays the same. The measures of position are multiplied by b and you add a to it. And the measures of spread were only affected by the multiplying by b. So it wasn't affected by the adding of the a. Well, doing a linear transformation on a data set is no different than doing a linear transformation on a random variable. So basically, when you multiply a random variable by b and add a, the probability distribution of y has the exact same shape as the probability distribution of x, and the mean of your y's is going to be a plus b times the mean of your x's. Or in terms of expected values, the expected value of my y is going to be a plus b times the expected value of my x's. Okay, remember the expected value and the means are the same thing. And then measures of spread are just multiplied by b. So if the standard deviation of x is that, you multiply by b to get the standard deviation of y. Or standard deviation of y is b times the standard deviation of x. Absolute value, because remember, standard deviation can't be negative. Okay, and we could do similar things with the median and IQR, but usually we only talk about the mean and standard deviation of random variables. What about the variance? Well, if the standard deviation of y is equal to the absolute value of b times the standard deviation of x, then if I square both sides in order to get it into standard deviations, in order to get it to variance, then the standard deviation squared is the variance. B squared is b squared, and standard deviation of x squared is the variance of x. So as you can see, the variance of y is going to be b squared times the variance of x. So when I say measures of spread are multiplied by b, I mean measures of spread that are in the same units. If you have a variance, which is unit squared, you got to account for that. All right, so let's take a look at an example. El Dorado Community College. So El Dorado Community College considers a student to be full-time if they're taking 12 to 18 credit hours, or units. Hours. Sometimes we call them credit hours. So if you're a full-time student, here's a probability distribution of the number of hours that people take, number of credit hours. So 25% of people take 12 credits, 5% take 14, 15% take 18, and so on and so forth. So let's find the mean and standard deviation. So this is review from the previous section. The mean of my x's, also known as the expected value of my x's. We're going to use the formula from your formula sheet that says you sum your x sub i's times the probability of your x sub i's. We'll basically just take our outcomes x times the probabilities, and then we sum them all up. So we're going to show our work. We're going to take 12 times 0.25 plus 13 times 0.10 plus 14 times 0.05. And we're going to, and you can keep going with this if you want to, but if, I'm kind of showing my work, so I'm going to go plus dot dot dot. Now, if you want to do, if you want to do it by hand, type them all in and type it in your calculator that way. However, if we want to use our calculator to do it, then we need to input this table into our calculator. So I'm going to do that right now. Let me pause the video. All right, so I put this into my calculator under x's for xxx for my x's, and then p of x for my probabilities. So if you recall, in order to find the mean and standard deviation, by letting the calculator do the brute force, the grunt work, I guess, we go to Menu, Statistics, Stat Calculations, One Variable Statistics, because this is still one variable. However, we have our x's, and then we also have that frequency list. Remember, our probabilities are like a frequency list. So that's the only extra part, is that we got to put in that frequency list. And if we look up here, the mean is 14.65. That looks about right. We got some 12s, we got some 15s, we got some 18s, but it looks like on average, kind of right somewhere in between those two. Okay, that's the expected value. Interpret it. When randomly selecting a student at El Dorado Community College, we expect, let me rephrase that, sorry, the number of credit hours we expect that student to have is 14.65 credit hours on average. All right, I don't really like the way that sounds. Sorry, I don't know if I could probably word that better, but say something about when we're randomly selecting a student at El Dorado College, we would expect that student to have 14.65 credit hours on average. I think that's better. I should have said we expect that student to have 14.65 credit hours on average. Whatever, either way, right? Standard deviation. Okay, so we got to show our work again for this. Now I know the standard deviation, it's right here on my calculator, but we have to show our work. So this is the square root of, you're going to reference your formula sheet. What we're going to do is we're going to take our outcomes. I'm not going to show you the formula. To review the formula, go back in your notes. It's right here. And that is on your formula sheet. But that was from the last lesson. You should be comfortable with this. So you take your outcome minus your mean, square it, that's your deviation squared, and then multiply by the probability. Plus, do it again for each one of them. 13 minus 14.65 squared times 0.10 plus ... Add them all up, take the square root of all of them, and that will give you the 2.056. I'm going to write it as 2.06. What does that mean? When randomly selecting a EDCC student, the number of credit hours for the student typically varies by 2.06 credit hours from the mean of 14.65. So not everybody has exactly 14.65 credit hours, right? There's going to be some variability. On average, people are about 2.2 credit hours away from the mean. So sometimes they might be 1 credit hour away from the mean, sometimes they might be 0, sometimes they might be 2, 3, 4, but on average they're going to be about 2 credit hours away. All right, so that's all review. Please, guys, show your work or you will lose points on your test, guaranteed. All right, so now let's actually do a transformation on this. This is what this unit's all about. Suppose El Dorado Community College charges $100 per unit for tuition. Colleges do this type of thing, only they probably charge a lot more than that. So let T be the tuition in dollars that a randomly selected student pays. So, for example, if I'm taking 12 credit hours, then I'm going to pay, my tuition is going to be 100 times 12, or $1200, so $1,200. So this is a new probability model. In fact, we can actually make the probability model on our calculator. So let's put in our TTTs, our tuitions, is going to be the formula. I'm going to take my x's, vars, x's, and I'm going to simply multiply it by 100. So these are the probabilities associated with, or these are the tuitions, and these are their associated probabilities. So I have a new probability model where my t's were all of my x's multiplied by 100. But I don't really have to put this in the calculator and rerun the program. I can just, find the mean and expected value and standard deviation. So find the probability distribution for t. Okay, so I did that. I'm going to just leave it in my calculator, I guess. I don't want to. Let me pause the video. All right, so here's my probability model for t. I basically took my x values and I multiplied them all by 100. So this is going to be dollars. So $1,200 is going to happen 25% of the time. There's a 30% chance that student is going to have a tuition cost of $1,500. To find the expected value, so my linear transformation is simply multiplying by 100. So its expected value is just what you'd expect. It's 100 times the expected value of x. That is 100 times the 14.65 that we got before. So your expected tuition that you're going to pull in per student on average is 1,465. And again, show your work, do the calculation. Standard deviation. The standard deviation of t, because we're multiplying, measures the spread r multiplied. So it's going to be 100 times the standard deviation of my x's. That is 100 times, what was it, 206? 2.06. So a standard deviation of $206. So the tuition is going to be about, on average, $1,465, and then the typical deviation from the mean for each student would be about $206, okay? How does the shape, center, spread of the random variable x compare to that? Well, the centers are multiplied by 100, the spreads are multiplied by 100, and the shape is the same. Now, we actually never looked at the shape of the original. Should I have done that? They never asked me to look at the shape. Maybe I can, I'm kind of running. Let's just take a look at the shape. You do need to know how to do this. If you want to take a look at the shape of the original distribution, we make a histogram. I put in my x's. Now I have to add a summary list here. So don't click here and add the probabilities, because that's not going to, it's going to make a scatter plot. You go to Menu, Plot Properties, and you add a summary list. Number 9. So there's the distribution. As you can see, 12, 15, and 18 are more common than the rest, because those are, usually college credits are 3 credit classes. But sometimes they have 2 credit or 4 credit classes. So if you take a mental picture of that, now let's create the distribution for T's. Now I got tuitions on the bottom. And as you can see, the distribution has got the exact same shape. Looks a little bit different because there's some gaps, but if I were to make my bins wider, if I were to make it 100, I think you're going to see it looks almost exactly the same. And alignment, I guess we should set the alignment to 1200. So as you can see, that looks exactly the same as the other distribution. So the shape of the distribution doesn't change, and the standard mean and standard deviation are multiplied by 100. All right, so now we're going to add something, but I'll leave that for the next video, or we'll maybe pick up right here at the start of class tomorrow, okay?